Hey, good morning, geometry. Today is Wednesday, April 8th, and got a couple requests about a problem to do. So I am going to do number 5. And number 5 brings us back to chapter 8, where we have to do a little bit of trigonometry. So we'll kind of review that as we go. And I'm going to do this all in one take. So hopefully it goes well. There might be a couple interruptions, we'll see, but you can always fast forward a little bit on your YouTube video if you need to. So we're back to looking at regular polygons, and when we looked at that in section 10.3 and looking at your quizzes from yesterday, it looked good that everybody was using the correct area formula. So our area is going to equal 1/2 ASN. So we got to find out what the apothem is. So that would be looking down at our regular polygon, that would be this right there. We also need to know what our side length is, and then we also need to know what our number of sides is. So what I'd like to do is I just like to organize my variables over here, and then we just find each of those three. The only thing we know the number of sides, and this is an octagon, is going to be 8 total sides. So that's all we know so far. We still need to find out what's the apothem, and then what's the side length. So the side length, I'm just going to put a little s right here. I can find out what the length of this is, and then we'll talk about what we need to do to find the full length of the side, all the way from there to there. But I want to focus on this triangle, because this triangle is what we're going to use to find the apothem and then find that S value. And I'm just going to kind of create a little bit bigger triangle that's similar so we can kind of look at it a little better. So that would be my apothem. This would be my radius going to the edge of the triangle, and then this would be my S. So there's my A, S, and then this ends up being my 10. So one thing we talked about in section 3 was the angles of these triangles inside of here, these central angles. We can take 360 divided by the number of sides. So 360 divided by 8 would tell me the angle of each of these triangles in here. So 360 divided by 8 means that that is a 45-degree angle. Then, since this apothem cuts those triangles in half, this angle inside of here is going to be a 22.5 degree angle. I'm going to highlight that in green. So this angle right there is 22.5. Okay. Now we get into a right triangle where we only know one of the sides, so Pythagorean theorem isn't going to work, but we do know an angle, so we have to use SOHCAHTOA. So that's what we are going to use here. And I apologize, some of my writing is kind of hard to do because I'm writing with my mouse, but we'll be using SOHCAHTOA to find these values. So I like to circle my vantage point, so here's where my angle is. And then labeling my sides, always start with your hypotenuse would be this, because your right angle is right here. This is going to be my adjacent side, which is also marked the apothem A, and then this is going to be my opposite side down here. Let's find the apothem first. So the apothem from this vantage point represents the adjacent side. 10 represents the hypotenuse, so adjacent and hypotenuse, I'm going to use cosine. So I set up my problem. It's cosine of 22.5 equals my apothem over 10. And to solve this one, I just multiply by 10 on both sides. So my apothem is going to be 10 times the cosine of 22.5. So 10 times the cosine of 22.5, we can actually head to calculator. Make sure, just a quick reminder, make sure your calculator is in degree mode. So I'm going to go down and make sure that degree is black with white letters. That means it's in degree. And I'm going to take 10 times the cosine of 22.5, and we get about 9.2. I've been getting some questions about this. Just round these trig answers to the nearest tenth, and then when you put them into your calculation, your answer, your final answer, may be a little bit different than the answers we gave you. That's because there is some rounding that's happening, so don't worry about that. But we ended up getting 9.2 for our apothem. So I'm going to go up to my apothem, and we're going to record that as 9.2. Next, we're going to find the side length, which I'm calling just this half length of the side right here. I'm calling that S, and then I'm going to be using that as the opposite leg with my trigonometry. So anytime I'm using the opposite over hypotenuse, in this one, we are going to use sine. So opposite over hypotenuse uses a sine. So we go sine of 22.5 is going to equal my opposite, which I'm calling S, over my hypotenuse, which is 10. If you're wondering how I'm writing this S over 10, it's just the opposite over hypotenuse. So I got to make sure I write that ratio as the opposite over hypotenuse, because that is what sine is defined as. And once I get this solved out for S, I'm going to again multiply by 10 on both sides. So 10 times the sine of 22.5 degrees. And we'll head to our calculator again. 10 times the sine of 22.5 gives us 3.8. And going back to the problem, 3.8 would just be this half length. So you can think about, well, what would I do for the full length from here all the way to here? Well, I'm going to double that. So I'm going to take this answer I just got, I'm going to times that by 2. So 7.7 ends up being my length of the side of my octagon. So I'm going to go 7.7 ends up being my side length. So it works out pretty conveniently when you get the radius that represents the hypotenuse of your right triangle. The apothem is your cosine. The side length is your sine, but then you have to make sure that you're doubling that. Once we have all our values, we can put those in. So area equals 1/2 times my apothem, which is 9.2, times my side length, which is 7.7, times my number of sides, which is 8. And we'll clean this up a little bit. So we'll head to the calculator. And I use 0.5, so 0.5 times 9.2 times 7.7 times 8. And we get our area is about 283.4. And yeah, number 5, the answer says 282.8. So if you're within 5 units, you are correct. So especially as the numbers get bigger, you will do a little rounding as you go. So the answer that I gave for this was 282.8. So that was with a little bit different rounding. 283.4 is just fine. So let's head back. So final area we will get is 283.4. So we are 6/10 off because of that little bit of rounding. And since this is area, this is going to be my meters squared. So there would be my final area result. So each of these in this section will be given the radius, and you'll use your SOHCAHTOA to help you find those missing sides. Just keep in mind that when you do find the opposite leg here, that's only half the side of an octagon, so you will need to double that, which is timesing by 2. Hopefully this helps. Keep giving me your requests. It's pretty easy to make these videos, so I can help you with any problems you need. Also, you can check in on Google Meet when we have those hours from 11:30 to 12:30. But if you have any other times that you can jump on, you can just shoot me a quick message and I can turn it on and we can meet for any of those problems. All right, I think this worked. We'll post it up on our updates and hopefully you can check it out. Thanks.